So basically this is a question about why isn't z is the square negative the square root of x squared plus y squared differentiable at 0, 0? And maybe what's a criteria for establishing when something is differentiable? Okay, so on this one, I'd say, all right, let me take the partial with respect to x of z. I'm going to notice that, let me see, in the x direction, right? That's really me kind of looking at this and thinking, okay, I'm going to assume y is constant, right? Let me assume y is 0 quick. Notice that z is the absolute value of x, right? You see that? Or minus the absolute value of x anyway. So this partial, right, has a slice that looks like this. This thing's not, that's not going to happen. Right? You could show this with a limit, or you could just notice that it's got a cusp there. Right? And so if it's got a cusp there, this thing's definitely not differentiable in that direction.
Yeah, this whole thing is an upside down cone.
Yeah, or you could notice the whole thing is an upside down cone, right? Which is also clearly not going to have a tangent plane at the top, right? But maybe what would a good criteria be? And the cheater criteria for this is, and this is sufficient, like this is enough, but it's not actually required. You can get away with just a tiny little bit less than this. So sufficient, not necessary. Both the partials have to exist. So partial of z with respect to x and partial of z with respect to y. And we said that existing wasn't also quite enough, and it's not. But existing and being continuous on some little neighborhood is. So exist and are continuous at least locally. And an easy way to establish at least locally continuous is to take a derivative again. You guys see that? So you could do this. You could take the partials, check that they both work, right? So you get something out of them, and then check that that's continuous, at least nearby.
You take the other 4.
Or you could take the other 3 partials, and as long as those are continuous at that point, you're okay. You would have a problem if they were continuous and not, or sorry, if they existed and weren't themselves continuous, at least right at the point. That's cool with this? So, the cheater criteria, and again, this is a little bit much, but this is the easy one to check. Just, do they exist? Are they at least locally continuous? Like, if they're not continuous, you know, on the other side of the field, who cares? As long as they're continuous in some little ball right here, I'm okay. Cool? So like these one, on this one, the partial of z with respect to x doesn't even frickin' exist at 0, 0, right? Okay, that's some serious problems. That's not gonna work. If it did exist, I would check, is it continuous at least nearby?